Okay, so here we are, number 7. We're going to finish, the plan today is to finish 12.1 and then 12.2. Okay, so the pattern continues. So they're giving us, so this is all about, 12.1 is the intro to sequences and series. And so we're looking at this pattern. Write down the nth term of the sequence. So what's the formula for the nth term? What do we mean? Well, this is the first term. This is the second term. This is the third term. This is the fourth term. And so how can we write a formula for like the nth term? That's what they want. What's it going to be?
6n minus 1 and plus 1.
So Abdul, what do you think?
6n.
6n?
Negative 1.
And then we'll do the negative 1 trick. Good. So far, so good with the 6n, though. Everybody see what Abdul's saying? He's saying, look, what is, don't worry about the negative positive, we'll handle that. But he's saying, look, isn't this 6 times 1? He's observing, right? And isn't this 6 times 2? The second term is 6 times 2. And isn't this 6 times 3? The third term is 6 times 3. So in general, it's just 6 times n, huh? See the pattern there? Whatever your term, like fourth term is 6 times 4, isn't it? See the pattern Abdul is observing? So the nth term is 6 times n. Yeah, but then what about the negative positive thing? Remember how we learned to make signs go back and forth? It's negative 1 to the n or n plus 1, depending on how you want it to start. Remember that? Mm-hmm. We want it to start positive, don't we? Mm-hmm. So do we do n or n plus 1? N plus 1. N plus 1, good, because when you plug in 1, it'll be 1 plus 1, it'll be 2, minus 1 to the 2 will be positive 1. It'll start positive, won't it? Does everybody see that? Negative 1 to the 1 plus 1 will be, when n is 1, you'll get negative 1 to the 2, which is positive, right? So for the first term, it'll be positive. Mm-hmm. And then when you go up to 2, when you go minus 1 to the 2 plus 1, when n is 2, that'll be, well, I'm probably getting confusing there. Yeah, when n is 2, then it'll be minus 1 to the 3, which will be minus 1, won't it? It'll go back to negative. See how that'll work perfectly? It'll start positive and then go negative, positive. So there it is. Whoops. There is the formula for that sequence of numbers.
Okay.
What's under the 6n?
Nth. I just wrote nth. We're just finding that. That's the nth term. On that. Now that's the nth term. That's the formula for finding the nth term.
I don't even know what 8 is saying.
Yeah, let's talk about, so on 8, a sequence is defined recursively. Recursively. Now, yeah, like what's a reoccurring dream? Well, a dream that you had before, you have again, right? So a recursive sequence is one that goes back. It refers to terms you've already done. That's what they mean by a recursive sequence. It's terms you've already done. So what they're saying, so let me try to help you with the language they're speaking here. They're saying A1 is negative 1, sorry. They're saying first term, that means first term. First term is negative 1. And then they're saying the nth term is n minus a sub n minus 1. What does that mean? That means nth term, that's what a sub n means. I'm trying to make my a's a little bit nicer there. Is n minus, and a sub n minus 1, that's the previous term. Everybody, now why am I calling that the previous term? Because it's n minus 1. That's 1 back, huh? Does that make sense there? right? N minus 1 is 1 less than n. It's 1 before. So we have the nth term, and then we have 1 right before it. So what they're saying is any term is n minus the previous term.
Oh,
That's what that formula is saying. That's why it's recursive, because it refers back. It reoccurs. It refers back to the previous term. So saying any term is n minus the previous term. N minus 1 is the previous, 1 back. So, okay, so let's try to, they want me to go A1, A2, A3, A4. Let's give it a try here. So A1, well, they're just handing me that, huh? That's just negative 1. So what's A sub 2? A sub 2 is going to equal, what does the formula say? So any term is n, the term number, minus the previous term.
so 2 minus the negative 1?
So it's 2 minus, yeah, the previous term, negative 1.
Oh, so we plugged in the first one that we got.
Yeah, in fact, let me go slower. Basically, notice 2 is being plugged in for n, right? So let me just be consistent and plug that 2 in for n everywhere. Probably be helpful. It'd be 2 minus A sub 2 minus 1. Now notice this is low down. This is subscript, which means it indicates a place. So 2, I just put in the 2 there, the 2 there, the 2 there, right? So A sub 2 is 2, a big 2, minus A sub 2 minus 1, which is a big 2 minus A sub 1, right? 2 minus 1 is 1. So A sub 1 is the previous term.
Negative 1.
See that? So it's, yeah, 2 minus, whoops, running out of room here, negative 1. 2 minus
3.
negative 1, so it's 3.
Okay.
Positive 3, huh?
And then it would be 3 minus
Yeah, try the next one.
3 would be 0. Okay.
Yeah. So the next one, A sub 3.
And then we level off.
A sub 3. So just plug in 3 for n. Plug in 3 everywhere for n. Gonna get 3 minus A sub 3 minus 1, which is 3 minus A sub 2. See how that's the previous term? See how it's always calling us back to the previous term? Yeah, so it's going to be 3 minus, and what's the previous term?
0.
The previous term is 3, so this will be 0. See what that formula is generally saying? Previous term. So one more, A sub 4. A sub 4 is, yeah, so plug in 4 this time, huh? We're going to get 4 minus A sub 4 minus 1, which is 4 minus
0.
A sub 3, which is 4 minus 0, yeah, 4. Got it? See how it's just going back to the previous term. It's called a recursive formula. That's kind of a big thing in like computer science. I know these days a lot of programming languages now are what are called recursive languages. It's kind of a lot of the way you said that with everything I said. A lot of the way the logic is going in computer science. So okay, so I'll do the first one. All right. Did you guys get those other ones there? So A sub 2. So just plug in 2. So the formula is A sub n is A sub n minus 1 plus 7d. So I'll just plug in 2 for n everywhere. So far so good. I just plugged in 2 for n. And so then that ends up becoming A sub 1 plus 7d. So see how it refers back to A sub 1, doesn't it? And so what is A sub 1?
A.
A plus 7d. And that's all we can do is just say A plus 7d. It's just all letters, huh? Not good. Can you find A sub 3? Plug in 3 for n everywhere.
I hope this is easy.
So it's a sub 2 plus 7d. Always refers to the previous term. It's recursive. So a sub 2 is a plus 7d. Well, here, let me try to use the colors to help.
Previous term plus another 7D.
Yeah, so, right. So it's a plus.
14D.
Exactly. We good there? Is that making sense? And the rest are the same. Just keeps adding 7D, huh? Next one's going to be a plus 21D, and then a plus 28D. So it's just going to keep adding 7D. That's what this basically says. Any term is the previous term, add 7D. Makes sense? All that? I'll move on if you're good. Yeah, Becca.
We're just, like, the a sub 3 minus 1 is telling us that that's really a sub 2
Mhm.
at 70.
Right.
Okay.
Right, and so a sub 2 is this, right? This is
Right.
a
Okay.
sub 2, yeah. And then add 7D, exactly.
Can you make the next exam like 30 questions?
Just all these? 30 of these?
Yeah, so we can
Just-
get like lots of points.
Just lots of, just add the previous term. We go, we get that weird, big, strange symbol.
Why did I have to make a K?
I see too many K's in him.
Yeah.
1B.
I don't know.
Do you look at that and feel like saying, it's like Greek to me? Sorry, I couldn't resist. It is Greek, isn't it? Yes, right. Sorry, there's just not many good math jokes. So, you know,
Two different Q's.
there's a few medium ones, and I just got to pull those out every now and then. So, it's just not a humorous field. Okay, so what are we going to do? What does that symbol mean? So we're in the intro right now. This is chapter 12. We're in the intro section. So we're kind of getting the language down. And then we're going to jump into 12.2 here in a few minutes where we'll start getting more specific. But right now, it's just get used to the way they talk in the field of sequences and series. So what is that big thing? It's a big Greek. What letter in the Greek alphabet is that? What does it sort of look like?
Epsilon.
It looks like an E.
It's sigma.
It's sigma?
It's sigma, yeah. Epsilon's kind of like it. You're thinking of that E. Epsilon looks like that. It's the lowercase epsilon. Anyway, that's sigma, which is a what? An S. It's a big Greek S, is what it is. Doesn't it look sort of like an S? No? Anyway, and that's to remind you of the word sum. So I'm saying that to help you know, when you see that, just think S, sum. So what that thing is saying is add up. Sum means to add up, right? Add up this formula as you plug in K, 1, and then 2, and then 3, and then 4, and then on you go, and then add them up, sum them up. That's what that's saying. So, for example, let me change it to just be what if you start here, and up here is where you end, and let's just make it 3, just to show you a more concrete example. What if that just said 3? What would they want me to do? They would want me to take the K plus 8 formula.
Starts at 1.
Yeah, and plug in 1. So you'd get 9, 1 plus 8. And then take the K plus 8 formula and plug in, I can't do it here, 2. And you get 10. And then take the K plus 8 formula and plug in 3. And you get 11. And then do what with those numbers?
Sum them.
Add them, sum them. You'd get whatever, 30. Does that make sense what it's saying, how it's speaking, this new language? So that big Greek symbol is a big Greek S. It stands for sum. It means add these up, start at K equals 1, go to whatever the top number is, just plug into, it's like a function, huh? You're just plugging into a function. Okay. So they didn't say 3. They said n. So let's do the actual question now. They said n. So I still start at 1, huh? So I'm going to take the K plus 8 formula. I'm going to start at 1, and they want the first term down. The first term is going to be 9. And then K plus 8 again. Now plug in 2. Second term is going to be 10, just like we had a minute ago. And then dot, 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 they want the last term. Over here is the last term. What's going to be the last term?
Infinity?
You end at what?
N.
N. So if I take the k plus 8 formula and I plug in n in the k slot, remember, k is a dummy variable. It's just holding a spot like a function, like f of x. So don't let that k confuse you. It's just a slot is all it is. So it's going to be n plus 8. We're done. So just like we put the 1 in there and the 2 in there, we put the n in there. And there it is. So we're just getting used to this language, what they mean when they write these strange, foreign, literally, Greek symbols. That okay? Try number 13 there. They have that formula. Can you read that? I can make it a little bigger. It's the sum from k equals 7 to n of minus 1 to the k ln k.
Okay.
So they want first, second, third, and last terms. So where are we going to start? What do we plug in first? Notice the bottom.
Negative 1 through 7.
7. You actually start at 7 with this one, huh? Yeah. So the first thing, so you start with 7, and you end. So they can start you anywhere. It doesn't have to start at 1, in other words. They can start you anywhere. So we start. This will be minus 1 to the 7 ln of 7. And what is minus 1 to the 7? Yeah, that's that negative positive switcher. Toggle switch, I call it, right? Like a light switch. Toggle means back and forth, two states. So negative 1 to the 7th is negative because it's an odd amount of negative signs. So it'll be negative ln 7. So that's what goes here. That's the first term.
So they're saying type an exact answer in simplified form, so we just stick in the formula?
Just minus ln 7.
Minus.
Because minus 1 to the 7th is negative 1.
Okay.
That's what they mean by simplified. They don't want that 7th power thing there. Second term, minus 1 to the 8th. ln a. You just go up by 1. Once you start, you just go up by 1 every time in the plug-in. So minus 1 to the 8th. So negative 1 to the 8th, is that positive or negative?
Positive.
That'll be positive, huh? ln to the 8. So just ln to the 8. ln of 8, I mean. And then negative 1 to the 9, ln 9, that's going to be negative ln 9. Negative ln 9. Now, what's the last one?
You have to put the whole formula in, right?
You do, exactly. Yeah, the last one, we don't have any choice. It's going to be negative 1 to the n, ln of n. Is that confusing with the double n's there?
Oh, so you don't actually have to add all these together.
No, we're just listing them right now.
It's getting an exact answer.
Yeah, no, we'll add them later. In about an hour. Not much later. But yeah, is that good there? That's just making sure we understand the language right. This is the intro section. I always liked it when I was in a new area of math because the intro was easy.
It wants an exact
basic.
answer.
Yeah, and those are exact answers.
Oh.
It means don't give me a decimal. When it says exact, it means don't give me a decimal because you'd have to round it and then it wouldn't be exact.
Right.
Just leave them like that. All right, shall we move on to number 14? It's already on the screen there.
Sure.
Well, it's kind of disrupted by these things, so I'm going to move it up. You guys okay? You got that copy down? I'll move on to 14. So they're going to have us do the same thing but backwards. They're saying, all right, here's the series. Here it is. Which one of these formulas produces it? Notice they don't have none of the above. Isn't that nice of them? They're far nicer than I am. Bless you. So it's got to be one of those four. So we can, I would probably just take A and give it a try. Maybe it's A. Take A and see what A would produce. How about we do that? Let's just take A up here. And say, all right, A, maybe it's U.
I think it is.
You think it's A? Is that what you said? Let's give it a try. They're very similar. The differences are small. Right? I mean, they all look pretty similar, don't they?
13 plus 4 is 17, so I think they also.
So, okay, so let's start. What do we do first? How do we find the first term? So you plug in 1, right? Put a 1 here and a 1 there. What are you going to get? 5/6. Right, y'all seeing that? What's the first term supposed to be?
4/5.
Not A.
So it has to be something that starts at 3.
Are we good so far? Is everybody seeing why A failed? So I started to try to produce the terms that A is telling me to produce. I put in 1, I got 5/6. It's supposed to start with 4/5. So it's not A.
Maybe it's C.
How about B? Let's start B. Let's just do the start right here. Put in 1 for B. What are you going to get?
5, 6.
Which is wrong also.
Yeah.
C.
Let's start with C. Put in 1. What do you get?
4/5.
Ah,
But you also get 4/5 for D.
right. So look at D. Put in 1. 4/5.
The
So
end
both
term-
C and D look good at the start.
The end term is 17, so 14 plus 3 is 17, 13 plus 3 is 16.
Good job.
Yeah.
Right. So everybody good that they start. Both C and D start well, but only one of them finishes well. Let's do the finish. The finish is it ends at 14 or it ends at 13. Which is appropriate? Well, if you plug in 14, if you plug in 14 here, you get what? 3 plus 14? 17 over 18. Is that where you're supposed to end? Yeah. C it is. D, if you plugged in 13, you'd get what? What is that? 16, 17. That's not right. It's supposed to end at 17, 18. That's easy enough, right? Just getting used to the language. How about 15? Same kind of thing. They want you to just finish the sigma notation. The sum from k equals 1 to what of what formula will produce that. So we're working backwards again.
To the end.
See what you can do there. So they want this thing and they want the formula. They want the end. Up there's the end, right? The start is 1. They want the ending place up there, and they want the formula. So, okay, let's start with the formula. What formula do you think we should put over here? Yeah, we'll get to the ending. Why don't we do the formula first?
It should be
K plus 1 on the bottom.
You see that this is basically telling us the formula. But I've got to write it with what letter? K, not N. 6 to the K over K. Now why? Well, because K is the dummy variable that they're using. Right? Everybody says it's kind of like a function. They could use this X. This would be X and X. And they're just saying whatever we use here, plug it in there and there. It's just holding a slot. That's all it's doing. So the K is going to be the counter. It's going to count through 1, 2, 3, 4, and plug in every time, right? And now, where does it end? Yeah, it ends at N, because the last one you're going to plug in is N. That's the ending spot.
Wait, repeat the end one more time.
So the way these things work, like look back to this one. The last one you're going to plug in is that top number, huh?
Right.
So what's the last? How am I going to get this last term?
Okay.
I'm going to plug in N into the K slot,
Right.
the dummy variable, the spot. Yeah, so you'll start by plugging in 1, and then 2, and then 3, and then 4, and end by putting in N in both spots, and you'll get that last term. Is that comfortable? You used to that language? All right, I think that's it for this section, isn't it? Isn't there just like number 16 or
Is it really?
I thought there was like 27.
16? Yeah, can you do that one? Try that one.
Yeah.
Try just writing them out. You know, it's summation notation. Sigma, the sum from k equals 1 to 20 of 4. Well done. Okay, so here we go. So we start at 1 and we end at 20, right? Now the trick is there's no place to plug the k in, is there? If it said 4k or 4 plus k or something like that, then I would, have a spot to plug in the k. But there's no place at all to plug in the k. So what's the first term? Well, it's just 4.
Yeah.
What's the second term? It's 4. So the first term is 4. The second term, right? Because there's no, you still do the different terms. The counter still counts. K is 1, K is 2, K is 3, K is 4. But there's just no place to plug in the actual K number. It's just 4. They're all just 4. And this is the 20th, right? There's 20 terms. You start at 1, you end at 20.
So you're just multiplying by 20 times 4.
Exactly. It's just 4 times 20. It's 80.
So we did want to be
Yeah, so they want the final sum. Find the sum on that one. They just want to make sure you're speaking this language okay. Try 17. So 17, there's only 4 terms, right? You start at 1, end at 4. Plug in 1, plug in 2, plug in 3, plug in 4. And add those up. So if I plug in 1, it's at 11 for the first term.
So 8, yeah.
okay.
Plug in 2,
15.
get 15. Everybody see what I'm doing? I'm just taking that formula. You start at 1, you plug in 1, plug in 2, plug in 3, plug in 4. Plug in 3. 19. Plug in 4. To 23.
68.
So what are those? And then we're doing what with those numbers?
Adding them.
Adding them all up because it's an S. It's a Greek S, which stands for sum, sigma notation. So add them up. Somebody got that total there?
68.
68.
I think. I hope so.
Yeah, got that?
Are we
Okay.
gonna do this faster?
Fast.
Look at it, so we don't have to.
Oh yeah, we're gonna get some patterns, and yeah, in the next section, we're gonna start making some key observations. So right now it's just getting our feet wet. We're just dipping in the water. But Renee's anxious to dive in, so we're gonna go right on ahead.
I'm good with that.
You good with that? I think we're close to being done.